Okay, so we are going to be looking at projectile motion maximum height today. So what we looked at in the meeting yesterday is that the equation h of t equals h sub 0 plus v sub 0 t minus 16t squared gives the height of an object in feet t seconds after it's thrown into the air. So in this equation, that h sub 0, that h naught, you could call it, it's our initial height. And then, oh, sorry, this should not have a T right here. And then that V sub 0, that V naught, that's our initial upward velocity. So whenever we have a problem like this, if we have a pumpkin and it's launched into the air from an initial height of 7 feet and an initial upward velocity of 85 feet per second, what is the maximum height the pumpkin will reach? And especially if we use Desmos, this turns out to be fairly simple to do once we get the equation set up. Now, first, I would like to sort of explain. When you launch a pumpkin into the air, it's going to follow a path something like this, and that's going to hit the ground. Well, you have two directions that pumpkin is traveling. It is traveling vertically, so it's traveling up, at least at first, and then it's also traveling horizontally. Okay, so this initial upward velocity is the part of the velocity that's going upward. It's a little bit hard to figure out because if you shoot a radar gun at this pumpkin, it's going to give you total velocity. Now, if you shoot a pumpkin straight up into the air, then all of the pumpkin's velocity would be initial upward velocity. But if it's launched at an angle, like we were looking at in those videos, then your velocity has an upward and a horizontal component. So for this, we're going to be given the initial upward velocity, so it's not something to worry about too much. But I just wanted to point that out. It's not very easy to find that initial upward velocity, and we'll see that later in the week as we go on. But they're giving us the initial upward velocity here. So our formula up here is h sub 0 plus v sub 0 t minus 16t squared. So in this case, h of t is going to equal h sub 0 is our initial height, and our initial height is 7 feet. So we're going to put that here. Sorry about that bad writing. And then our initial upward velocity is 85 feet per second. So we'll put 85. And for the 85, we've got a t that goes with that because it's v sub 0 times t. And then we always end it with our gravity, which is minus 16t squared. And so this is our equation. And all I'm going to do is just type this into Desmos. So if you just go to desmos.com, we're going to type this in. H of t equals 7 plus 85t minus 16t to the second. And it's going to give us a graph. Now this graph does not look all that good because the pumpkin goes a lot higher than 10 feet. So I'm going to go over here to the little wrench, and this will give you your settings on your axis. We need our y-axis, our vertical axis, to go a lot higher than 13 right here. So I'm going to change this maybe to 50 and see if that works. And it's not enough. I could just sort of scroll. I could just sort of move this up now if I want. And see right there is the maximum point. Or I could go back. Let's go back just so we get a little better picture. Okay, so we were right here. If I go and I make that maximum like 150, then I can see the top of this graph really well. And right there is my maximum height. And so I've got two numbers at that point. Desmos, all you got to do is click, and it'll show you that maximum point. I've got 2.656, and I've got 119.891. So on this graph, the x-axis is your t, that is your time, and your y-axis is your height. So if you think of this, your t is your x coordinate, and your height, or your h of t, is your y coordinate. So if we want to know the maximum height of this pumpkin, we want to know the y coordinate there. So that y coordinate is 119.891, and this is measured in feet. That is height measured in feet when we're using this equation. So that pumpkin would reach a height of 119.891 feet. That would happen at 2.656 seconds. That would take it that long to reach its maximum height. But we can find the maximum height there using Desmos. Okay, let's do some more. Okay, some of the problems you're going to see don't ask you to plug the numbers in. They just give you the equation. This makes it even easier because you don't have to worry about even plugging the numbers in the correct places. So they give you the equation that gives the height of a ball in feet 10 t seconds after it's thrown out of a second-story window. What is the maximum height in feet that the ball reaches? So all I'm going to do is go over here and type in that equation. So I've got 21 plus 84t minus 16t squared. And you can see here, whenever I type that in, I can see that I have a maximum height of 131.25 feet. So 131.25 feet. And somebody's throwing something really hard. It's probably not a very realistic problem right there. You see our answer's fairly close to our other problem. Now, if I look at that problem, I can tell the initial height, the initial height is 21 feet, and the initial upward velocity is 84 feet. I can tell that by where the numbers that are in the equation, but it didn't ask us for that for this problem. All right, let's do another one. This one's a little bit trickier. This information up here at the top is just the same. It just gives you that formula. But our question really starts down here at the bottom. If a soccer ball is kicked from the ground with an initial upward velocity of 27 feet per second, what is the maximum height that the ball reaches? This one is a little bit tricky because I only see one number. All I see right here is that 27 right there. I do not, and that 27, it's the initial upward velocity. I do not see the initial height. But if we think about the situation, we are kicking a soccer ball from the ground. Okay, so if you're kicking a soccer ball from the ground, its initial height is 0 because it's on the ground. So in this equation, we would have h of t equals, we would have an initial height of 0 plus initial upward velocity of 27. I'll put the t beside it. Minus 16t squared. So for this problem, we, let's go back over here. We don't really have to type that 0 in. We could if we wanted to, but I'm going to leave it off. 27t minus 16t squared. And so on this graph, oh, that's not minus. There we go. So on this graph, you can see that's much, much lower. So I'm going to zoom in a little bit down here on this, even though you don't really have to, because Desmos will give you that value. And so we see 11.391 feet. So this soccer ball would only go 11.391 feet in the air. That would be the maximum height. Now, if we kick that ball harder, you can see if you have initial upward velocity that is higher. If you make that 50, you can see the soccer ball goes higher. If you kicked it more easily, if you just made it 10, then it's going to go lower. So you can kind of see what happens with your soccer ball there as you kick it. All right. We've got one more example that we're going to do. This is another problem that just gives us the equation. The equation is h of t equals 15 plus 35t minus 16t squared. And it gives the height of a pumpkin in feet t seconds after it's thrown into the air. Find each value. So in this case, they gave us the equation, and they're asking us to find the pieces of the equation. So first ask for the initial height of the pumpkin, and that initial height is going to be this value right here that does not have a t with it. So that would be 15 feet in this case. B, ask us for initial upward velocity. And so initial upward velocity is the number that is beside the t. It's at 35. So our initial upward velocity of the pumpkin would be 35. And velocity is measured in feet per second, kind of like miles per hour. You've got to have a distance divided by a time, so feet per second in this case. So the pumpkin was launched at a rate of 35 feet per second. And then the last part asks us for the maximum height of the pumpkin. So we've just got to type in the equation like we've been doing into Desmos. So 15 plus 35t minus 16t squared. And if you go over here to the maximum point, you can see that you've got 34.141 is your maximum height. So maximum height of the pumpkin would be 34.141 feet. Okay, so that sort of summarizes how you're going to find the maximum height when you're dealing with projectile motion. And this will have an assignment that goes with it. If you'll go to Canvas there's going to be an assignment called Projectile Motion number 1, and you're going to take that quiz that goes with these notes here. Please make sure that you get at least an 80 on that. It'll tell you there how many questions you've got to get right. So make sure that you do that and turn this in. Thank you.